Hello and welcome to this seventh algorithm selection and development lecture in this course Mastering Artificial Intelligence. So in this lecture we will move on from defining the problem, understanding the problem and finding out what type of data, what type of output do you want and the evaluation. We will talk about three things. One, we will summarize what did we learn in the previous section about data understanding and preparation, the next step in researching, selecting and developing appropriate algorithm. And then we will talk about how to research algorithms in architecture. And then we will start talking about model selection and evaluation, which will cover over many lectures as we go forward. Right. So let's quickly summarize data understanding and preparation that you need to do after having understood the problem, defined the problem, and understood the various type of outputs you need. You will need to explore and analyze the available data because that will determine your model. Basically, what you need to understand there is its characteristics, its distribution of the data, and the quality of data. And we have talked about how to do that in the previous section in quite a lot of detail. Then what we do is we pre-process the data by handling things like missing values, outliers, and feature scaling. And we again talked about these things. And then we split data into training, validation, and testing sets for model evaluation. So that's what you do in data understanding and preparation, right? Then we get into researching algorithms and architectures. We know the problem that we want to solve, the type of output we want, and the type of data that we have. Now we conduct literature review and research to identify relevant machine learning algorithms and deep learning architectures that are suitable for the problem domain, including the data that have been given. So we start searching for these data. And basically, we search through the literature and we review the search to find what are the right machine learning algorithms or deep learning architectures that might be suitable for the problem that you have defined. Then you consider both traditional machine learning algorithms there. And what are the conventional or traditional machine learning algorithms like linear regression, decision trees? We will talk about support vector machines and deep learning architectures like CNN, convolutional neural networks, recurrent neural networks, and transformers. And we will talk about all these as we go forward in the future. Then we evaluate the strengths and weaknesses uh, of and applicability of different algorithms and architectures. Now, there that you do this evaluation based on the problem requirements, data characteristics, and computational resources. So that's how you evaluate the different algorithms. You figure out their strengths and weaknesses and applicability. Based on this strength and weakness analysis of all the different algorithms that you have researched and picked up, what you do is then you select candidates, those potential machine learning algorithms or deep learning algorithms that you think can help you build that right model and that you do based on their suitability for problem and the data. So problem and the data are the critical anchors, pillars on which you build, figure out and evaluate the various candidate machine learning algorithms. Having selected the candidate machine learning and deep learning algorithms, what you need to do is to train and evaluate multiple models, not one model, but many models that using appropriate evaluation metrics and validation techniques. Now, what are these evaluation metrics and validation techniques? Cross validation, hyperparameter tuning, and we will talk a lot about this in detail how to do that. So, what is cross validation and hyperparameter tuning? So let's look at cross-validation first, and then in greater detail we will talk about hyperparameter tuning. So cross-validation is a resampling technique that is used to assess how well a predictive model generalizes to an independent data set. So you have the trained data, you have validation data, testing data. Independent of all that, the new data set, how does this model work? So that's what a cross validation is. And what does it involve? It involves partitioning the available data into multiple subsets, what is called folds. So multiple subsets of data are created called folds. And then the model is trained on the subset of data, the training set, and evaluated on the remaining subset, the validation set. Now, this process is repeated multiple times, with each fold serving as a validation set exactly once. Now, the performance metrics are averaged across all folds to obtain an overall estimate of the model performance. Common type of cross-validation include k-fold cross-validation, stratified k-fold validation, and leave one out cross-validation. Now, cross-validation helps to mitigate issues such as overfitting and provides a more reliable estimate of model performance compared to a single train test split. Right? Right. So what is next? So having looked at cross-validation, we will now look at hyperparameter tuning. In the next set of lectures, talk about three types of hyperparameter tuning: learning rate and gradient descent, number of hidden layers in neural network, and regularization strength. So thank you so much for watching this seventh algorithm selection and development lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any question. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need to.